In this lecture, we're going to explore the t-test as a means of comparing statistically the results obtained when we have two different groups of cases or research participants. And so central to executing the t-test is to find the critical t-value, and we'll step through that in this video. In finding that critical t-value, we do need to compute the degrees of freedom. Now, when we are using the t-test to compare the results of two different groups to each other, we do lose 1 degree of freedom for each group. Therefore, our calculated degrees of freedom in this case, because we have two groups, is our total sample size, the sum of the cases or participants in each group, subtract 2. And then at that point, we then go to the t-table with our degrees of freedom that we calculated and the established alpha level to find the critical t-value. And the critical t-value is often expressed in this manner, where we have the t for the degree for the chosen alpha level, and often this is reported as a 0.05. Sometimes it's reported as a 0.95. Those are considered to be equivalent with respect to the type 1 error rate. And we also report the degrees of freedom, and both of these are often used in subscripts or in parentheses following the t symbol. Now, in this example, we're going to examine the question of whether university graduates and high school graduates differ in terms of intelligence scores. And so what we see on this table are the results of the study, which sampled a number of university graduates and high school graduates for aptitude test scores for intelligence. And the question that is stated, is there a significant difference? The word difference is critical here because the term difference is not specifying a direction. So therefore, when we carry through with the t-test, we're going to establish a non-directional retain or reject rule. So as stated previously, our first step is always to calculate the descriptive statistics. And so we have an average score of 460 for the university graduates, a standard deviation of 92, and we had a total of 102 participants among this group. For the high school graduates, we see a score of 442. We have a standard deviation of 57, so a lower standard deviation among the high school students or graduates than we had for the university graduates. And we also have a different sample size as well, and we'll explore that a little bit later. In moving through the process to answer the question, we follow the exact same set of steps. So we state the null hypothesis. Automatically, that moves us to the alternative hypothesis. We choose an alpha level and whether our question is directional or non-directional. We then state the rejection retain rule, and we can do that once we look up the critical t-value. Step 5, we go through the mathematics of calculating the t-statistic specific to the collected data. We then make a decision as in step 6 by revisiting the rule that we established in step number 4. We then write the conclusion in the context of the study. So if we start with the first two steps, because they do go hand in hand here, with the null hypothesis, we're stating that the population of university graduate intelligence scores will not be different than that of high school graduates, and so it's equal. So recall, the null hypothesis is automatically stated that it will be a null difference, no difference, so they will be equal. Alternatively, the next step is to state that they will be significantly different, or they will not be equal. Recall that the question asked for a difference and not whether one group was greater or less than the other group. And so without that directionality stated in the question, then we just go with the not equal sign. Moving on to step 3, we choose our alpha level and the directionality of whether it's one or two-tailed. So we're going to go with the standard 0.05 risk of committing a type 1 error. And we're going with the two-tailed non-directional approach, once again because in the stated question, the direction was not implied. The statement of examining a difference indicates that it is non-directional. We then move on to stating the rejection and the retain rule. So to do this, we need our t-table, and we have to find the degrees of freedom specific to this study. And so because we have two different groups of cases or research participants, we take the total sample size of both groups and we subtract 2. So we had 102 participants in one group, 117 in the other group. We sum these two numbers, we subtract 2, and we end up with a degree of freedom value of 217. And so with this value in hand, we can now go to the t-table and find the critical t-value, understanding that we also have to bring with us the alpha level of 0.05 and the fact that it is a two-tailed test. And what we see here with a two-tailed test, the alpha 2 symbol indicates that the 5% risk of committing a type 1 error is equally split between the low end, or the negative end, and the positive end. And so we have 2.5% in the shaded red region on the left, 2.5% in the shaded region on the right. So we go with the row that indicates alpha 2. Alpha 1 is the row if we decided to go with the directional approach, which is not applicable here. So we go with alpha 2. We locate the column for 0.05. We then go to our degrees of freedom column, and we go down and we look for the number corresponding to what we had calculated on the previous slide. And so we have 120, and then the next value up is infinity. So the difficulty with the t-table sometimes is that it doesn't always give us the exact degree of freedom that we computed from our research study. So if we scroll over to the column for the 0.05 level, we find that the critical t-value for 120 is 1.98. We find the critical t-value for infinity is 1.96, as we explored in a previous lecture. And the value of 1.96 at the degree of freedom of infinity is no different than that for the normal distribution. And so what we're left to do here is to state that rejection and retain rule. However, we don't have the exact critical t-value. So once again here, we have the critical t at a degree of freedom of 120 to be 1.980. That was obtained from the previous slide. At the infinity level, it's 1.96, but we see that with a degree of freedom of 217, it's somewhere between 120 and infinity, and we cannot use linear interpolation because we don't have the high end of this range to calculate that value. But because the critical t-values of 1.98 and 1.96 are very close to each other, then it would be perfectly reasonable to settle on a score somewhere or halfway between these two values. So for a t-value of 217, which is quite a bit larger than 120, although much smaller than infinity, it's perfectly reasonable to pick the number halfway between these two values. So with those two, with that critical t-value in hand, we can now move on to performing our calculations with the t-test. Remembering that the very first step was always to calculate descriptive statistics, because the data, in terms of the means, and the standard deviations separately for each group, as well as the sample size, will be needed. The first step is to calculate the standard error of the mean, and to do that we will need the sample size and the standard deviation. Once we've completed that step, we can then move on to calculating our t-value. And so recall, the standard error of the mean for the differences between the two groups is expressed conceptually as the squared value of the standard error of the mean for the first group. Added to that is the squared value of the standard error of the mean for the second group, which will then be taken to the square root. But now in this study, notice that we had different sample sizes. And so the equation on the right-hand side would typically be used where we would treat each group separately in this long equation to arrive at the standard error of the mean difference. In this example, I'm going to go with the conceptual relationship as a means of calculating the t-value. So to calculate the standard error of the mean for the differences, we have to first calculate the standard error of the mean for the first group, which is equal to the standard deviation of the first group. Remember, this is what we obtained from our descriptive data, divided by the sample size of the first group. We would then repeat that for the second group. And after calculating that separately, we find that once we calculate the standard error of the mean for the first group, we multiply it by itself, we take the square value, and we end up with an 82.98. We repeat the same process for the second group, we multiply it by itself, and we end up with a value of 27.77. We add these two values together, we take the square root, and we end up with 10.52. We now then look up our equation, our prescribed equation for calculating the t-statistic for the differences, for testing the differences between group 1 and group 2. And what we need to do with what we need for that equation is we need the average of group 1, we need the average of group 2, and we need the standard error of the mean differences between the two groups, which we just completed in the previous step. And so substituting the numbers, we have 460, which was the average for the first group. We subtract 442, which was the average intelligence score for the second group. We divide it by the standard error of the mean difference of 10.52, and we end up with a calculated t-value of 1.71. So moving on to making a decision for the rejection-retain rule, since the absolute value of 1.71 does not satisfy this condition here. So 1.71 is not greater than or equal to the critical t-value. Because this statement here is not true, this was stated a little bit earlier, we always do this in step 4, this is a false statement, so therefore we accept the null hypothesis. And therefore we write the conclusion in context of the study. And so the results here indicate that there was no statistically significant difference in intelligence scores between university and high school graduates. So this ends this part of our t-test unit.